Hello everyone. In this class, we are going to discuss about the problem on the turning moment diagram. So here is a problem on the turning moment diagram for a petrol engine in which the scale for the turning moment and for the crank angle is given respectively. And also he has given some areas here above and below the mean turning moment line, and also a mass of 36 kgs at a radius of gyration 150 mm is given, and also the engine runs at a speed of 1800 rpm. So using this data, we have to find out the coefficient of fluctuation of speed. Okay, so let us write down the given data first. So the turning moment scale is given as 1 mm is equals to 5 Newton meter. Okay, and similarly for the crank, it is given as 1 mm is equals to 1 degree. Okay, so this data we are going to use for finding out the maximum fluctuation of energy. Okay, so we will determine the maximum fluctuation of energy by using this data here from the diagram. But when you find out the value of that maximum fluctuation of energy, that value we are going to get in terms of mm square. Okay, so to convert that mm square into the actual units of the energy, we need to use this data here. Okay, so for that purpose, what I'll do here is I'll multiply 1 mm into 1 mm. So that is, so this 1 mm represents for the turning moment, which is 5 Newton meter into, and this 1 mm represents the scale given for the crank angle, which is equal to 1 degree. Okay, so this is equals to 5 into, so this 1 degree we have to convert into radians. That is 5 by 180 radians. So when I multiply this, so I am going to get this value as 536. So that is 5 by 36 Newton meter. 5 by 36 Newton meter. Okay, so now let us find out this maximum fluctuation of energy. So for finding out the maximum fluctuation of energy, I'm going to use this data given here. So he has given some areas here, both above and below the mean turning moment line. So the areas which are above the turning moment line are taken as positive, and the below are taken as negative. Okay, so first of all, let us assume the energy which is available at A is equals to E. Let energy at A is equals to E. Then the energy at B will be equal to the energy at this point. B will be equal to the energy available at the A plus 295. So why it is plus 295? Because this area is above this mean turning moment line. Okay, so that's why it is E plus 295, right? So then similarly, we have to find out the energy at C. So the energy at C will be equal to the energy at A plus the energy at B minus 685. Why it is minus? Because it is below the mean torque line here. Okay, so therefore it is E plus 295 minus 685. So that will give you E minus 390. Okay, so that will give you E minus 390. So similarly, the energy at D will be equal to this E minus 390 plus 40 at D. So it is E minus 350. Okay. So then energy at E will be equal to this E minus 350 minus 340. Okay, because it is a negative below the mean torque line. So therefore it will be negative. So that means E minus 350 minus 340. So minus 350 minus 340 will give you minus 690. Okay. So then energy at F will be equal to E minus 690 at F will be equal to E minus 690 plus 960. So that is E minus 690 plus 960. So that is plus 270. Okay. Then finally the energy at G will be equal to E plus 270 minus 270. So that is will be equal to E. So again this E is nothing but the energy which you have assumed at A here. Okay, so that is E is equals to energy at energy at A. Okay, so this is the complete cycle, right? So this we have completed a cycle here. From here the cycle repeats again. Okay, so now let us find out the actual what is delta E. So delta E is equals to, we know that delta E is nothing but it is a difference between the maximum energy and minimum energy. That is maximum energy minus minimum energy. Okay. So what is the maximum energy from this here? So which has the highest positive value? This one. Which has the highest positive value is taken as maximum, and which has the highest negative value is taken as minimum. Okay, so if I subtract these two, I'm going to get this delta E. That is E plus 295 minus E minus 690. Okay, so which is equal to, how much this will be? E, how much I'm going to get this one? Sorry, E and E will get cancelled. 295 plus 690. So that will give you 985 mm square. 985 mm square, because all these are in terms of mm square, I should write mm square. So now we have to convert this mm square into Newton meter. So for that I have to use this data here, this one. Okay, so that is 1 mm square is equals to 1 mm square is equals to 5 by 36 Newton meter. Okay, so then this will give you 5 by 36 into 985. It will give you 85.95 Newton meter, right? Okay, so now we also know that delta is equals to m into k square into omega square into cs. Okay, so we know m is given as 36 kgs here. M is given as 36 kgs. K is radius of gyration. It is given as 150 mm. So convert this into meters. So it will be 0.15 meters. And omega is equals to, we know that it is 2 pi n by 60, which is 2 pi into 1800 by 60. So that will give you 188.49 radians per second. Okay, now substitute this all the values in the above formula. So you get delta E is equals to 36 into 0.15 square into 188.49 square into CS. Okay, so what is delta E value here? So this one, substitute that value here. So we are going to get the value of CS. Okay, so the CS value will be 0.003.